Hello, all. Welcome to Career Launcher. Welcome for the next session on 150 must do questions. So, the second part, we looked at a mixed bag of, I would say, most expected kind of problems with new concepts or innovative style of problems that test our analytical reasoning skills, I would say. So with that theme, we have brought another session. So I hope that you would be participating in it and not just going through the video as such. So with that in mind, right, I would like to start with this session. Right, with 100 days left, I think this is the time to look at all the topics all together and look at all the types of different problems on it. All right, so here we go, people. Uh, just to remind you that if you're not already aware, that CL is out with its app both on iOS as well as Android. So you're suggested you can make full use of it. Live classes, practice, profilizer, study material, all of that is there, right? All in your hands. All right, so people, let's start with the session. Here we go. So we all know that CAT is having the maximum weightage on arithmetic as well as algebra. But at the same time, there are other topics too, like numbers, geometry, and modern maths, right? So we'll be looking at all of them as much as we can through these sessions, right? So let's dive in. All right. So the first question is something that we can call it an icebreaker, I would say, or an egg breaker. Icebreaker in the sense that I think all of us can try this one. It's a very basic logical problem. I was carrying 5 egg trays, each containing eggs arranged in a 4 by 6 grid. Okay. No egg slot in any tray was empty. Okay. Some eggs broke during transportation. Which of the following cannot be the ratio of broken to unbroken eggs? Well, so we have trays of eggs 4 by 6. So how many in fact eggs are there in each tray? Eggs per tray is simply, it's a grid of 4 by 6, so 4 into 6, you have 24 eggs per tray. You have 5 such trays. So how many total eggs do you have? Total eggs 24 times 5, right? 5 trays of 24 eggs, each 120 total eggs are there. Some of them broke. Which of the following cannot be the ratio of broken to unbroken? So it's a very simple question on ratios. You need to find that ratio from the options such that 120 cannot be divided in that uh, proportion, right? So for example, option A is definitely not our answer because 120 can easily be broken down into the ratio of 1 is to 11. Since 1 plus 11 is 12, so 120 is divisible by 12, right? So this the number of eggs becomes 10 and 110, right? 12 into 10 is 120. So just multiply these numbers with 10 and you have this being possible. So that's not my option because I'm looking for that ratio which is not possible. 1 is to 9, like similarly, is not my answer once again because 1 plus 9 is 10 and 120 is divisible by 10. So 1 is to 9 is 10. 10 into 12 is 120. So you can multiply these numbers by 12 and you can say 12 and 108 number of eggs. 12 were broken, 108 were not broken. What about 1 is to 14? 1 plus 14 is 15. So 15 into 8 is 120. So you can multiply these numbers with 8, right, to get the actual numbers. So 8 and 112, 14 into 8 and 1 into 8. 112 were fine, 8 were broken. So that is also not my choice. So therefore, that only leaves me with D. And yes, D is the answer, because how can you split 120 in the ratio of 1 is to 8? You can't, because 1 plus 8 is 9 and 120 is not divisible by 9. Right? If you say these are x number of eggs and these are 8x, then x plus 8x, which is 9x, if you equate that to 120, then you get the x to be a fractional value. Right? So, simple problem on ratios, that when a total number is given, uh, then in what ratio you can possibly split. It is only possible if the sum of the ratios is divisible by the total quantity, right? So, all right, people, now I think we can start attempting the next problems, right? So let's solve this all together, right? uh, Here we go, something on profit and loss. A stationery shop bought some pens at rupees 10, which were then sold in two ways. Either buy a single pen for rupee 20. Okay, so that's a 100% markup. You're selling at 20, which is double of 10, or a bunch of three at an offer price of 50. So why is it an offer price, people? Why is it an offer? Because if we go by the single pen cost, that is 20, then 3 would have cost you 60, but it's for 50. So that's why it's a bundle. So you get it for a little bit less. After selling all the pens, if the shopkeeper had an overall gain of 80%, then what proportion of the pens were sold in bunches of 3? All right, so I'm reading this very slowly so that you get the time to think on this and perhaps give me the answer on that. What do you say? Now, so there are two ways to deal with this problem. A more of a traditional variable based, equation based, I would say, approach. Or you can take this question and understand that it's basically the question is of averages in a way. You're averaging out the profit percentages which are split on a differential basis, which means, so I'll solve it by the smart approach. The traditional approach, I would leave that for you to try, and you can verify the answer from that approach. So I would say there is this bunch of pens which are sold for 20 rupees. So basically, you bought them for 10 and you're selling them for 20. So that's a 100% markup. So call that as bunch A. Just call that as bunch A of pens, right? So that's a 100% markup. So basically, I'm saying that this profit percentage of 80 is the weighted mean of the respective profit percentages of the two lots. So I'm saying that we can apply the allegation principle of weighted mean over here, and that can tell us the ratio in which the two groups of pens must have been sold. So group A of pens were sold at 100% profit, right? Group B, so you had three pens, so they costed 30 rupees. So this is for bunch A, this is for bunch B. So that bunch of three pens, they costed the shop owner 30 rupees, 10 into 3, and you're selling that for 50 rupees. So what is that in on a profit percentage basis, people? 50. So you're having a profit of 20 rupees on 30 rupees. So that's a 20 by 30 or a 2 by 3 profit in fraction, or in percentage that is 66 2 by 3. So therefore call that as bunch B. We are trying to find therefore that what proportion of pens were sold in bunches of 3, which means that this bunch B is what proportion of the total number of pens A and B taken together. So now coming back to the fact that we can use the allegation principle over here. So this 80 overall gain is the weighted average. So the crisscross difference rule of allegation will give us the ratio in which the two lots, the quantity of pens which were sold, right? 100 minus 80, 20. 80 minus 66.66 would be 13.33, or 13 1 by 3 would be, yeah, so 13 1 by 3, or 40 by 3%. So the ratio is coming to be this. We need to simplify that, I guess. We can write this as 40 by 3 and this is 20. I can cancel 20 on both sides. So this is 2 by 3 is to 1, or simply 2 is to 3. So from the ratio, I can tell that the fraction share of the bunch B, 2 is to 3 is the ratio. So out of 2 plus 3, 5, 3 is bunch B. So that's a fraction of 3/5, right? 2/5 were loose pens sold for 20 rupees, and 3/5 of them were sold in bunches of 3. Well, so as I said, we can solve it by the traditional equations, variables. Let's assume X as the number of pens sold as loose single pens, Y as the number of pens sold in offer price. We can go from that approach as well, right? But I think you should understand that the concept of allegation is the smart approach, right? I just took time to explain, but once you get this logic, you can do this. I think in less than 30 seconds if you get the point, right? 100, 66.66 overall 80. I get the ratio in which the two lots, the quantity of pens must have been sold. All right. So people, I'm looking out for your participation in the session. Uh, yes, let's gear up for the next one. Time and work. Okay, reading out for you people. Uh, Working alone, Aarti takes 125% more time to do certain work than she would to do it together with Bhavani. Okay. Working alone, the time taken by Bhavani to do the same work is how much percentage more than she would take to do it while working together with Aarti. Okay, let's understand what the question is saying. When a person works alone, obviously he or she will take more time with respect to uh, uh, working with somebody else. So when you work together, your rates get combined, you work fast, so time will be less. So Aarti is taking so much percentage more time, right? Now the focus in time and work questions is to establish the relationship between the rates of the persons involved. Typically when you're working with rate, you can easily apply the uh, ratio approach, or you can say the variation approach in solving the problems, right? Work is fixed, work is the same in both the cases, right? Because clearly it is said that Bhavani is doing the same work, right? Okay, so Aarti and Bhavani, we are trying to establish how their work rates get combined. Okay, I've got a very brilliant answer from Scale Up Stories. Yes, that's correct. Brilliant, brilliantly done. Very nice. Okay, let's discuss this. Thank you. Now, so when Aarti was working alone, she's taking what? 2.25 times of the time? 125% more. Means if she's taking one day, she's taking 2.2. I mean, sorry, if the working together, Aarti and Bhavani, if they're taking one day, then Aarti alone is taking 2.25 days, 125% more, right? So the ratio of Aarti's time working alone with respect to them working together is 2.25 is to 1. 2.25, or 2 and 1/4 is 9 by 4. So the ratio is 9 is to 4. I always I like to simplify the ratio in the fraction or the integer form. I want to get rid of the decimals. So that's why 2.25 or 9 by 4. So I would say if 9x is the days taken by Arti alone, right? Then Arti and Bhavani alone are taking 4x days. Or simply the ratio is 9 is to 4, right? So if 9 is to 4 is the ratio of the time taken for Arti with respect to them working together, 9 is to 4. So work being fixed, work is rate into time. So the applying the variation approach, the rate is inverse to this, right? The rate relationship is in the inverse ratio of 4 is to 9 is the ratio of the work rate. What? For Arti alone with respect to Arti and Bhavani working together. So it means that this 9 is the total rate of Arti and Bhavani, whereby Arti's rate is 4. So Bhavani's rate is 5 because the rates get combined. 4 plus 5 equals 9. Right. So we now have established the ratio of the rate of Arti to Bhavani, which is 4 is to 5. 4 is to 5, therefore, is the ratio of the work rate for Arti to Bhavani. Right, and their total rate is 9. This is the relationship of rate. Now we need to basically answer the question in the reverse manner. What if Bhavani works alone? So now we can see that the ratio is 5 is to 9 between Bhavani working alone and Arti and Bhavani working together. So this will give us the required percentage, because we need the percentage of time which Bhavani takes more to do the work on her own. So the rate is in the ratio 5 is to 9 in the two cases. So the time should be in the inverse ratio of 9 is to 5, right? 9 is to 5. So therefore Bhavani's time is 9 by 5 times as respect to them working together. 9 by 5 is 1.8. So that's an 80% higher time, right? So just a problem on establishing the ratio using the variation rule. All right. Good, good, good. So therefore emphasizing on the aspect that how problems can be solved using the ratio approach in time and work. Well, let's see next one. Here we go. Geometry. Yes, yes, yes. Good, good, good participation. Let's try this as well. Something to do with polygons. Now, let me start drawing the figure for over here. So in geometry, typically the figures you have to first of all understand carefully, right? You have to sketch the figure based on the description and label it correctly, and then see what we need to do. So ABCDF, it's a regular hexagon. All of us know a regular hexagon is basically 6 equilateral triangles, right? P, Q, and R are the midpoints of the sides A, B, C, D, and E, F. So they are alternate sides, A, B, and then not B, C, but C, D, and then not D, E, but E, F. So let me just start marking the things over here. All right, something like that. A, B. Now, so AB midpoint is P, and then this is Q, and then this is R. So with this figure, you're asked for the ratio of the area of triangle ACE to PQR. So let's first of all focus on this PQR triangle. It is very clear that each of the three sides PQ, QR, and PR are definitely equal, because the each of them are drawn in an identical manner, right? By joining the alternate midpoints of the sides of a regular hexagon. So it's a regular hexagon, the most symmetric hexagon. So definitely this PQR is equilateral. Now what about ACE? Let me draw it separately because it would become a little bit of mess in the same figure to understand. So I'm just drawing another hexagon. By the way, you can let me know if you're getting this, people. Now, so in this figure, I'll not draw PQR, I'll just draw ACE because we need to compare the areas of these two triangles, ACE. Now, don't you think, again, by the very symmetrical nature of this figure, this triangle ACE is also bound to be equilateral because each of the three sides are basically the shorter diagonal of a regular hexagon, right? So we have to establish essentially the ratio of the sides of these two triangles. Clearly, both of them are equilateral, right? Okay, so what I'm saying is, as far as so we need to in order to establish the required ratio, we should, let's say, start by assuming the side length of the original hexagon. So let's say that the side length of the equilateral of the regular polygon, let's say, is A, right? Okay, so in for as far as this triangle PQR is concerned, what I would do is just I would connect this diagonal AD, the longer diagonal AD. All of us know that this longer diagonal AD is having the length which is twice the side length of the uh, regular polygon, right? Uh, if I had joined the center of the hexagon to each of the vertices, then it becomes very clear that uh, from this center to this point is the side, because if you join this B to the center, you would get an equilateral triangle, right? As we know that a regular hexagon is 6 equilateral triangles. So with BC as A and AD as 2A, you have joined the midpoints of a essentially a trapezium BCDA. This is clearly a trapezium because obviously BC is parallel to AD, right? So therefore, the line joining the midpoints of a trapezium we know is the average of the two parallel sides. So the side length of PQ is average of A and 2A. So we can say that PQ therefore is A plus 2A by 2, the average of them, BC and AD, and hence it is 3 by 2A, right? Now coming to this triangle ACE, AB is BC is also A. Angle B is 120 degree, the angle of a regular hexagon. Obviously, ABC triangle is isosceles, so the other two angles are equal. So 120 remaining 60, split that equally as 30 and 30. So it's a 30, 30, 120 triangle. In a 30, 30, 120 triangle, all of us should be knowing that the ratio of the sides is 1 is to 1 is to root 3. So therefore A and A, so therefore this AC becomes root 3A. So we have the sides, and I think now nothing much challenging remains. So the area of ACE will be root 3 by 4 into AC square, and the area of triangle PQR will be root 3 by 4 into PQ square. So when you take the ratio, the root 3 by 4 factors cancel out. You're left with AC square over PQ square, right? Or simply AC over PQ the whole square, right? So this is root 3A, and this is 3 by 2A the whole square. So root 3 cancels here, and inside of the square you have 2 by root 3 left, the whole square. So that is a ratio of 4 is to 3, right? 4 is to 3 is the required ratio, right? So you should, all of us should know the geometry of a regular hexagon, and I think this question very nicely captures some basic concepts around that, right? So geometry, I think, is something that if you know the properties, right, and you love applying them, then it's fun, I would say, that if you are able to understand the properties and apply them in problems. So geometry, you can expect 2 3 questions on that, right? Makes up for a huge difference, right? Okay, now, okay people, something on algebra and a little bit of a hardcore problem for the next one. um, I have seen with my experience and having gone through, I would say, the historical pattern of CAT paper, which I have seen is that things which have appeared, things which have been obsolete for 10 years, 15 years, suddenly appear. So I brought a question here, which is a bit of a retro question in the sense that you can see it's a fourth degree polynomial. Now, we have not seen such a question in quite many years, but a bit of a hardcore question on algebra, and I think we should brush our concepts around it. How to solve this? How to solve a fourth degree polynomial? So, effectively, that is what this question is asking. You have to solve this equation, right? You have to solve for all the roots alpha, beta, gamma, and delta of this fourth degree equation. And then your answer that you need to mark is mod alpha plus mod beta plus mod gamma plus mod delta. Now, don't get under the impression that the answer is as simple as. Mm, so he's not asking alpha plus beta plus gamma plus delta. Try to understand. That's not the thing. Otherwise, this question was a cakewalk. All of us know from the sort of relationship between the roots and the coefficients of a polynomial that the alpha, beta, gamma, delta should sum up to 27 by 10, right? It is always the coefficient of x cube with the minus sign over the coefficient of x power 4. But that's not what he's asking, right? So we have to solve this properly because we don't know which roots are positive, which roots are negative. He's asking for the sum of the magnitudes of the roots. All right, so now I'm starting to explain this. If you get there quicker than me, then do let me know your answers. Okay, let's say. So let's check how do we do this. So do you see a pattern over here in the equation? Do you see a pattern in the coefficients? There is a 10 x power 4 and then there is a 10 in the constant term. There's a minus 27 in the x cube and there's a minus 27 as the coefficient of x. So the coefficients are symmetrically placed. Now, so what's the catch? The catch is this actually this question is of quadratic equations. Now, this is not a quadratic equation to look at, but it's a question on equations which are reducible to the quadratic form. A question appeared last year on the concept of x plus 1 by x square plus 1 by x square, x cube plus 1 by x cube. So this question actually is indirectly making use of that. You need to do a small manipulation. You need to divide the entire equation by x square. From there, the manipulation would begin. So what that would give you is, so I'm directly writing the equation by combining the terms, which when taken together would give us a simplification. So when I divide this entire equation by x square, then I have 10x square and I have 10 by x square. So 10 times of x square plus 1 by x square. Likewise, you have minus 27x and minus 27 by x, isn't it? So you have minus 27 of x plus 1 by x. And this minus 110 x square becomes the constant term, which is minus 110 equal to 0. All right. Now, do you see what we can do over here? I hope you can understand. The substitution that is required is to take x plus 1 by x as a variable, called that as t. And in that case, squaring both sides gives us that x squared plus 1 by x squared plus 2 equals t square. Or this thing, x squared plus 1 by x squared, can be replaced as t square minus 2 in terms of that. Okay, so for understanding, let me write this with a different color so that you can clearly see. Now we have changed our direction. So the equation becomes 10 times bracket t square minus 2 for this x square plus 1 by x square minus 27t and minus 110 equals 0. Now this has become a very nice quadratic to solve, right? So simplify further, 10t square, you have minus 20 from here, minus 27t is there, and minus 110 minus 20. So minus 130 is 0. Now we need to do the splitting of the middle term. Remember, we are solving for t, and t is x plus 1 by x. So we will eventually get two quadratic equations by solving for t, because we'll have x plus 1 by x equals the value of t. Now I hope to get some kind of rational solutions from here, because all the options are like that. Them basically being decimals, right? There is no option with fraction with the square root in that or something like that, right? Okay, so I need to do the splitting of middle term, because doing by the quadratic formula would be really time consuming. uh, I'm not relying on calculator for doing this. So 10 into 130 or minus 130 rather is minus 1300. So you need to split minus 1300 as a product of two factors whose sum is minus 27. Yeah, good, Saloni. 52 and 25. Yeah, a little bit hidden trial. You will reach there, right? Correct. 52 and 25 is the required split. Good, people. I am liking this. You're solving with me. So, can you also confirm the answer quicker than me? Okay. So 10t square minus 52t plus 25t, right? And minus 130. So that would be what can you take common from here? 2t, and then you have 5t minus 26, and then from here you have 5, and again the same 5t minus 26. Yeah, right. So I'm getting 2t plus 5 and 5t minus 26 as 0. That gives me that t is either minus 5 by 2 or 26 by 5. Okay, very nice. So we have two quadratics, that either x plus 1 by x is minus 5 by 2, or x plus 1 by x is 26 by 5. Now, if I have this as minus 5 by 2, then I should be able to express minus 5 by 2 in the form of a number plus its reciprocal, the way I have the LHS. I'm trying to say, instead of now creating a quadratic by doing x squared plus 1 upon x equal to minus 5 by 2 cross multiplying, doing the traditional way, right? Just do number fitting. Minus 5 by 2, isn't it minus 2.5? Minus 2.5 means basically minus 2 and minus half, which tells me that x is nothing but either minus 2 or minus 1 by 2. I hope you agree with me, right? X plus 1 by x is minus 5 by 2, which is minus 2 minus half. So either x, you can substitute x as minus 2, so it makes sense, minus 2 and plus 1 upon minus 2, or minus half is also fine. Put x as minus half. So minus half plus 1 upon minus half, which is back to minus 2, right? Perfect. Likewise, 26 by 5 is 5 and 1/5. So it has been also nicely put together. This number has been put in a very nice manner so that we can again understand that x plus 1 by x is 5 plus 1 by 5, which means that either x is 5 or 1 by 5. So there you go. Those are the those are the four roots: minus 2, minus half, 5, 1 by 5. Now, what are they in the decimal value? Right, you need to add their magnitudes, right? So 2 and half, so 2.5 from here is the sum of the magnitudes of the roots, and 5 and 1 by 5 or simply 0.2, so 5.2 from here, so 5.2 and 2.5, which is 7.7. All right. Okay, so equation reducible to the quadratic form, right? So next time if you see such a problem with symmetric distribution of the coefficients with a fourth degree polynomial, this is the manipulation that is required. All right. Yes. Okay. Very good. Very good. So we are learning. We are learning, right? We are learning some nice logics over there. Okay. Now, do you like modulus? I have seen that very few people like this topic. I've seen that, but I personally like modulus, and I would like you to like that as well, modulus. Now, I've deliberately put this question with an intention, a big no. You know something? I would make you fall in love with modulus. Actually, I want you to fall in love with algebra, right? And my message, which I have given in I have recently taken a whole algebra module recently, if you have seen that, and those who have gone through those sessions would have noticed that how much I have brought to forth the uh, emphasis on graphical interpretation with algebraic questions, right? Okay, so you have a key equation here. The question is very simply how many solutions exist for this equation, and both sides you have modulus. Now the traditional algebraic approach is open the modulus with the plus minus n sign and solve for it, and check for all the valid solutions, right? So the thing is that takes time. That takes time, right? Opening the modulus and then you'll get quadratic, right? Two times you will solve that, and it's not just that do the quadratic equation give you the solution or not. It's also that the roots which you get, do they satisfy the original constraint or the condition or the assumption, I would say, based on which you are opening the modulus. For example, what I'm trying to say, if let's say I am opening this modulus such that I'm keeping plus sign on both the sides. So if I'm doing it like this, okay, x square minus 6x plus 8 equals x minus 3, and this quadratic, whatever roots I get, okay, so those roots should also satisfy the original assumption, which is that this expression was positive and this expression was also positive, right? So that takes a bit of a time, right? Now, I would not do this question by this approach. I would not solve this question algebraically. I would just do this question in less than a minute. And what I would do? I would say I'm looking at this equation as if I'm reading that f1x equals f2x. What I'm saying, try to understand. I'm saying let's plot y equals f1x on the graph. Let's plot y equals f2x on the graph. Let's see their points of intersection, because f1x equals f2x, graphically it tells us that they are their graphs are intersecting. So we are looking for basically the intersection points of these graphs on the xy plane. So that is something that we can do. Look at this, f1x. Your f1x is basically in the modulus. So this is a quadratic which can easily be factorized. 8 is 4 into 2 and 6 is 4 plus 2. So this easily factorizes as x minus 2, x minus 4 with the modulus on that. Mod of x minus 3 is very simple, right? So both of them are very standard, well-known graphs, I would say, which can easily be plotted. None of them would go below the y axis. Uh, Salonil, watch out for this. Okay, look at this carefully. Now, what is the graph of f1x? So originally, if there was no modulus, this would have been a quadratic, just the usual, with the roots as 2 and 4. So 2 is there and 4 is there, and it would have been a quadratic, and like this it would have gone down, and then it would have come up. Now the role of the modulus is whatever is negative to make it positive. So this downward thing would actually come up. So there will be a horizontal, there will be a uh, vertical reflection, right, of this portion. It will get erased, and it will be replaced by a portion which is positive. So that's the role of the modulus. That is what it is going to do. Now I'm very good to see people are trying this one. Saloni is saying 0, Abhilasha is saying 1. None of you have actually taken my approach, which is the graphical approach. You're going to see what is going to happen. This is the graph of f1x. I hope everyone would agree. If anybody has any doubt, I can explain this again. Do let me know. What is the role of modulus function? Whatever is negative, it makes it it flips that value. Mod of -5 is +5. So whatever was the negative portion of the parabola would come above the x-axis, right? Whatever was already above the x-axis, it would stay where it is, right? So this red graph is f1x. Now I would draw the other graph of f2x with a different color so that you can see that clearly. Let's choose green. So this is the point 3, mod x minus 3. So it is 0 at the point 3. Then mod x minus 3. So it is just the graph of mod x, but shifted at x equal to 3, right? So it would go something like that here, and something like that here. So what do you see now? What do you see in terms of the points of intersection, my dear? 1, 2, 3, 4. Yes, Kunal, 4. People, my message is, if you want to fall in love with algebra, start doing curve sketching, start building your confidence on graphs, right? People think algebra is all about variables, equations, solving them, blah blah blah. It is to a very large extent, but lot of questions you can do it, you can analyze the problem much easier by taking the given functions to the graph and then understanding what is happening over there, right? Okay, right. So I did not solve for the values of x. Did you see? I was not interested in finding what are the values of x. I'm not interested in finding the roots, because that is not that is not what the question is asking. He's just asking how many solutions are there. So there they are. I definitely know there are 4 solutions. Clearly, this line x minus 3 here and 3 minus x going here, definitely it is going to intersect the parabola at 2 points on the right side as well as the left side for sure. The weight is there. There is no doubt on that, isn't it? Okay. All right, people. So this was this one, right? So next time you see something on modulus, or I would say anything on algebra, you feel stuck, think, can graphical analysis help me over here? If the graphs, if the equation is a standard function like a parabola, like a exponential function, 2 power x, 3 power x, we all know they're standard graphs, right? Log, basic standard functions, no, even trigonometric functions, right? We should all know the standard functions and their graphs. Okay, here we go. Next one, something interesting, geometric counting. Something interesting, geometric counting. Now let's see. So something to do with geometry and something to do with PNC. So it's a mix of both the worlds. It's a question of counting or PNC in a way, in respect of some geometric situation. So that's what this question is. Sir, we can square both sides. Yeah, Kunal. So, I'm leaving the algebraic way to solve this question up to you. Okay. What I'm showcasing is, yeah, Kunal, good, good. So, I'm not denying all of us can get four solutions from the algebraic approach. Correct. You can square both the equations. That's what Kunal is saying in the last question. Just square it. Yeah, correct. We can do that. And so I'm not denying it. Definitely we can do it. And what I'm showing is I would say an innovative approach, right? Something that helps us do it, I think, a bit faster if you are comfortable with curve sketching, right? Okay. Now let's see this one. Yeah. Okay, so using the vertices of a regular polygon, using the vertices of a regular polygon, how many sides this regular polygon have is not given. Question is saying 60 triangles can be drawn which share exactly one side with the polygon. Uh, yeah, Kunal, that's fine. The solutions are not integers. I've never said that the solutions are integer. I have never said that. I have not even calculated them. Did you see that? I did not even calculate the solutions. I just figured by graphical interpretation that the two curves are intersecting at 4 points. Right? Now, so using the vertices of a regular polygon, 60 triangles can be drawn which share exactly one side with the polygon. Uh, Saloni, actually, the point is, okay, let me come back for a minute on this. I think people have a bit of a doubt on this. Can I erase this? I think this is clear. Let me just spend 1 more minute on this problem. So, everyone, so people are asking that how do we get the solution? By the way, if you have to solve this algebraically, I don't think so. Squaring is the way. The way is simply open the modulus in two ways. So algebraic way to solve this question is if you see a question of the like this, you have that mod of f1x equals mod of f2x. The way this question is there. So there are two ways this modulus opens. Either f1x equals f2x, then this would be equal, or f1x equals minus of f2x. That is how the modulus opens, either with the positive sign or with the negative sign. Now, what is the condition based on which this modulus has opened in this way? Here, the condition or the assumption, I would say, is that f1x and f2x are of the same sign, which simply can be written in the way that f1x into f2x is more than 0. So that both of them have opened with a positive sign, you can say it like that. Okay, so Saloni, the point is it's not just one quadratic, there are two quadratic equations that you'll have. One by opening in this way, another by opening in this way. F1x is minus of f2x, and in that case the condition is that f1x and f2x are of opposite signs, or you can say that the product of the two functions is negative. So this will be one quadratic, this will be another quadratic. Two quadratics will give us four solutions, right? So that's the algebraic approach, and I'm saying that for me is a bit time taking. Right? I just solved it or analyzed it graphically. All right. Okay. Uh, okay. Now, okay. So here, let me discuss what's the concept here. Geometric accounting again. Questions on PNC which involve geometric concepts. Okay, so this is something again um, which has not been asked, which has been asked, I would say, uh, in recent years as well, but with less frequency. But Again, it can come up and some innovative questions like this. So the concept is, if so we don't know the number of sides of this polygon, this regular polygon, so that's what we have to find, right? So let's call that as n, which we are trying to find, which is the number of sides of this regular polygon. So what's the concept? So if there is a n-sided regular polygon, how many such triangles can be obtained, which the question is saying 60 of them, the question is saying, sharing exactly one side with the polygon. So in terms of n, how many such triangles can be obtained? We have to count that. We have to form an we have to find a formula for that, you can say, right? We have to figure that out. So since I don't know the number of sides, I cannot draw it, but I need to draw it for purpose of representation of the problem. So I'm just trying to put it in some way with the I'm just let's say denoting some points, some sides. Let's say in general, let's say the points or the vertices are like this: a1, a2, a3, and dot dot dot. Right. So I don't know where it closes, where it ends, but I need to mark some points so that I can explain or I can understand the situation. So I'm drawing some points, some vertices over here. Okay, I think that is sufficient, and it can continue till I don't know where. Okay, so I'm leaving it open ended. Now what I'm saying next is, people, the way that such a triangle can be obtained is, first select a side which is common. How many such triangles can be obtained, which the problem is saying? Now, how many triangles can be obtained having exactly one side common? Number of such triangles is, so it's a two-step process, right? You have need to have exactly one side common with the polygon. So obviously there are n sides to a n sided, I mean there are n sides to a regular polygon you have taken, right? So in n ways you can select that common side. First you select the side which is common with the triangle in n ways. Over here I have drawn marked some points a1, a2, a3, dot dot dot. Let me just say I'm highlighting this side. Let's say a7, a8 I have just highlighted. So I've taken that side as the common side. So to form such triangle, first you select the common side. That means you have selected two vertices of the triangle. Now to complete the triangle, which means to finish forming the triangle, you only need to now select the third vertex, and then your triangle is done. So how many options you have in succession to choose the third vertex? So fundamental counting principle is being applied. You will multiply the number of ways of first choosing the common side, and then the number of ways to choose the third remaining vertex of the triangle, right? You cannot choose a8 and a7, obviously they are out of the picture. A9, if you form a triangle a7, a8, a9, then both a9, a8 and a8, a7 will be common sides. So this will become a triangle not having one but two sides common with the polygon. So you cannot choose a9, just the vertex which is just the next adjacent vertex to a7 and 8. Likewise, you cannot select a6 also. Again, a8, a7, a6 would be a triangle having two sides common. But all the remaining vertices can be selected. Agree? For example, that a5 lying over there would be such a triangle, a8, a7, a5, right? That would have exactly one side common. Or for that matter, any of the remaining, how many? N minus 4 vertices, because you have crossed out 4 points a9, a8, a7, a6 in order to choose the third vertex. So this 60 in terms of n is the value of this n into n minus 4. Right, people? Isn't it? Agree with that? So in terms of n into n minus 4 triangles can be formed having exactly one side common with the polygon. So now coming back to the problem, what is n? This 60 is 10 into 6. 10 into 6, n into n minus 4. 10 and 6 also differ by 4. Here also we need a difference of 4. So what we are getting? We are getting n as 10. So it's a decagon. It's a regular 10-sided polygon. Hence, finishing the problem, the required angle is, all of us should be knowing that the internal angle of a regular polygon of n sides is always 180 minus 360 by n. So for n equal to 10, you get 180 minus 36 or 144 degrees the answer, right? Perfect. So something on geometric counting. Okay, let's take one last problem, people, for today. Let's see. Here we go. Okay. Maxima and minima and statistics concepts thrown in over there. Let's see. Now, people, looking out for your answers on this. Yes, all of us can try this one. Very interesting question. So questions on maxima and minima are asked in different styles, different ways. I have brought a word problem style, maxima, minima. So statistical based problems have appeared in different ways in recent years, not just in quant, but heavily some DILR problems also have come with the logics of statistics being used in them. So with that in mind, I hope you would want to try this one with me. Let's see if you get this. Let me know. It's a theta problem. Each morning, Shailesh takes some almonds along with milk given by his wife. Very nice. He never counts them, but one day his wife told the following facts. So, a very doting husband who trusts his wife never counts the almonds given by her, but the wife reveals the following facts about the almonds. In the last week, you had at least 5 almonds each day. Okay. So start noting the things on the sidelines. Minimum is 5. You did not get 4 or less than that. You had minimum of 5 each day. We are talking of 7 days. We are talking of 7 days. So there are n equal to 7 days that we are tracking. The minimum value is 5. The mean as well as the median number of almonds eaten for the week was 8. Mean is average, which is 8. Average is sum of values upon number of values. So sum of values upon n is 8 and n is 7. So the sum of the number of almonds eaten by Shailesh is 8 into 7, 56. So Shailesh had total of 56 almonds on the week. And median is also 8. Median is the middle value. Median in this case is the middle term. Since there are 7 terms, so median is going to be the 4th term. So the 4th term, which means the 4th highest value, is 8. Does not mean that the 4th day of the week he had 8 almonds. It means that when the number of almonds eaten by Shailesh are arranged in an ascending order, then the 4th highest number is 8. The mode is unique, but the same number of almonds were not eaten on more than 2 occasions. When is the mode going to be unique? When a number repeats for the highest number of times and there is no other number which repeats as many times. But the same number of almonds were not eaten on more than 2 occasions. So there is no value which repeats for thrice or more. So any number can only repeat for twice at the most. And since the mode is unique, it means that there is a single number which repeats twice. It means that there is a single value which is the mode which must repeat twice. So the mode is unique and the mode must repeat only twice and there is no other number which repeats. Right? So all that with being in the mind, we have to do one thing. At most, how many almonds could Shailesh have had on any day in the last week? Now, so what do we do? This is a classic question, and such questions have been asked quite frequently in the recent years, where you have to do number fitting. Some statistical constraints and conditions are given, which I have already highlighted and outlined over here. We have seven values: 1, 2, 3, 4, 5, 6, 7. We have to decide what numbers should be put over there so that one number is maximized. We are trying to find at most how many he could have on one particular day. Let's say this is the number of almonds arranged in the increasing order. So let's start putting the things together. We have seven values, minimum is 5. So I'll not write 5 right now, but I'll say mean is 8, sum is 56. So my total value is 56, right? Median is fourth term, so fourth highest value is 8. That's the exact number. I have a mode, unique mode, so one number will repeat twice. Avilasha, some constraint you are uh, missing out on that, I guess. Now, so what do we do? Obviously, we are trying to maximize this highest figure. So obviously, the mode which is there should not be this highest value, because then I would be sharing this highest value once more. Padam got this. Brilliant, Padam. Very nice. Good, good, good. So people, the logic is obviously I would want to minimize all the other numbers. Well, obviously, why would I repeat the highest number? That would be wasting a lot of number of almonds, isn't it? So the mode which is unique must be kept as the smallest number, so that I'm repeating the smallest number, so that a very small value is given away twice. So I would say minimum I could go for is 5 almonds. I would repeat that 5. So I would keep a 5 for the smallest two values. Now I know I cannot repeat any other number, but still I would want to keep the minimum possible numbers. The only constraint therefore that remains is uh, that you cannot repeat any number. So keeping in mind that you have to keep unique numbers now, so you cannot repeat 5 again. So you would keep this least, which is 6. Since the fourth highest term is 8, so the next numbers must be more than 8. You cannot say, okay, I'm putting this as 7. That is going against the whole logic that the median is 8. So the next numbers have to be more than 8. So the minimum that you can do is 9, and then you can do a 10. 5, 5, 6, 8, 9, 10. These are the smallest figures for the other 6 days. What does that add up to? 5 plus 5 is 10, 6 18, 16, 16 8 24, 24 9 33, 10 43, 56 minus 43, 13. Thank you, Padam. Thank you, Kunal. So some people got this, right? So such kind of problems on statistical based constraint driven maximization minimization, uh, right, are something that is quite relevant, I would say. Okay, so that brings us, people, to the conclusion for today's meeting. So it was a good session, I would say, very with a lot of interesting problems that we saw and good participation from all. I'm happy to see you, and we'll keep on meeting, right, and keep on looking at such things as the 100-day to cat is in front of us, right? So thank you so much. Thank you. Thank you. Stay connected, stay in touch, and uh, any queries, further things, do let me know on the chat box, or right, reach out to us. And thank you. Thank you. Thank you. See you. See you next time, people. Thank you. Thank you all.